Hello students, welcome to this lecture, and in this lecture we are going to discuss some CBSE pattern questions for the chapter integrals. So, in this chapter integrals we studied about indefinite integration, we studied about definite integration, their properties, their formulas, their applications. So, if we remember all of them, we can do these questions. So, let us move on to the first question. First question says that find the antiderivative of 2 minus 3 sin x upon cos square x. So, this is a 1 mark question. So, if we want to do this question, what we will say, that the integration of 2 minus 3 sin x upon cos square x dx, we can also write it like this: 2 sec square x dx minus 3 tan x sec x dx. What have we done here actually is we have separated this cos square x to two terms. So, I have put a cos square x here separately and a cos square x here separately. So, in that case 1 by cos square x becomes sec square x, and here sin x by cos x become tan x, and one more cos x becomes sec x. Now, we remember the formula which we studied in indefinite integration, that sec square x is a derivative of tan x. So, integral of sec square x is tan x. What is the integral of tan x sec x? That means which function gives the derivative tan x sec x. So, that is the function sec x plus constant of integration. So, this is what we get as an answer over here. So, let us move on to the next question. Next question says find the integral of x cube minus 1 cube root x to the power 5 dx. So, let us solve this question. This is also a 1 mark question, and here we have to intelligently use substitution. So, the question says x cube minus 1 cube root x to the power 5 dx. Now, what substitution we have to do here? We have to put x cube minus 1 as t cube. In that case, when we will differentiate, we will get 3x square dx is equal to 3t square dt, and we can cancel this 3. So, x square dx is t square dt. Now, this integration will become, since x cube minus 1 is t cube, so t cube cube root will be t. This whole term will become t. What will be x to the power 5? X to the power 5 is actually multiplication of x cube and x square. So, we can write x cube as t cube plus 1, and this x square dx will combine and give you t square dt. So, in this manner the substitution will help us to get rid of cube root which is present over there. Next will be integral of t to the power 6 dt plus integral of t cube dt, which is equal to t to the power 7 by 7 plus t to the power 4 by 4 plus constant of integration. So, we get the final answer as, since t we took as x cube minus 1 cube root. So, we can say x cube minus 1 cube root, that is 7 by 3 it will become, upon 7 plus x cube minus 1 to the power 4 by 3 upon 4 plus constant of integration. So, this is the final answer of the second question, which is also a 1 mark question, and we have to understand the application of substitution. Now, let us first erase this question, and then we will come to the third question which we have to discuss. So, the third question here is find the value of integral 0 to 1 tan inverse 2x minus 1 by 1 plus x minus x square dx. So, this is a question of definite integration as we can see. So, let us solve this question. This question says we have to find integral of 0 to 1 tan inverse of 2x minus 1 upon 1 plus x minus x square dx. So, we remember a property which we studied in definite integral. It says 0 to a fx dx can be written as 0 to a f of a minus x dx. Okay? its general case was a to b, and here it is a to b, and this will become a plus b minus x dx. So, this is a specific case which we also studied as a property. So, let us consider this integral is I. Now, we apply this property here. So, 0 to 1 tan inverse, in place of x we will now use 1 minus x, that is 0 to a minus x, minus 1 upon 1 plus 1 minus x minus 1 minus x whole square dx. So, this is what we get here. Now, let us simplify this. When we simplify this, what will be the numerator? Numerator here will be 2 minus 2x minus 1, which will eventually be 1 minus 2x. What will be the denominator? So, here it is 1, 1, 2, and 1 square is 1. It is with minus sign. So, 2 minus 1 will be 1. So, constant is 1. Here it is minus x. This give you after expansion minus 2x. With this minus, it will become plus 2x. So, plus 2x minus x will be plus x only. What else term we get? We get here x square, which has a minus sign over here. So, minus x square. Now, this can also be written as, since minus sign can be taken common and it can come out of the tan inverse, we can write it like this: 0 to 1 tan inverse 2x minus 1 upon 1 plus x minus x square. Dx is here also, dx is here also. So, we can see that this term can be written as negative of, we can interchange the place of 1 and 2x with each other. So, now if we observe this particular integral, what is this integral? If you see the question, this integral is same as the integral given in the question. So, isn't this I? Yeah, this is I. So, can we say that this is finally equal to minus I? There is a minus sign before it. So, what we have observed, that I after many steps and the application of properties became minus I. So, if we say that I is equal to minus I, what does it mean? Therefore, we can say that I is equal to minus I, which means twice of I is equal to 0, which means I is equal to 0. So, we can say that this integral is actually eventually 0. Okay, students? So, this was the third question, and it is also of 1 mark. Now, let us move on to the fourth question. Fourth question is of 2 marks. It says, find the integral of 6x plus 7 upon root over x minus 5 x minus 4 and this integral dx. So, let us try to solve this question. Fourth one. It says, find the indefinite integration of 6x plus 7 by root over x minus 5 into x minus 4 dx. So, first of all, what we will do? We will write this term in the denominator like this, that is x square minus 9x plus 20, after multiplying term by term and simplifying. Now, I want to write this 6x plus 7 as a constant into derivative of this term, which is under the square root. So, what is the derivative of this term? This has a derivative as 2x minus 9 plus another constant b. So, can we decide the constants a and b so that 6x plus 7 can be written like this? Yes. We write 6 is equal to twice of a, and we write 7 is equal to b minus 9 of a, which means a comes out to be 3, and if we put a is equal to 3 here, b will be equal to 34. So, we know the values of a and b. So, the integration I can now be written as, if we want to write 6x plus 7 as 3 times 2x minus 9. So, this becomes 3 times 2x minus 9, and the denominator is root over x square minus 9x plus 20 plus, we have a b constant also here. So, b is 34. So, integral of 34 upon root over x square minus 9x plus 20, here also dx you have to put, here also dx you have to put. So, what I mean to say that 6x plus 7 is actually written as 3 into 2x minus 9 plus 34, and we have separated both the terms. Why have we separated both the terms? You will just get to know this. So, if we separate these two terms, and if you suppose that this term in the under root is suppose u, then we know that we have taken the terms in such a manner that this 2x minus 9 dx is actually du. This is 2x minus 9 is derivative of this u, that is 2x minus 9. So, if you assume this as u, this term will become du. So, in the integration of this, 3 will come outside. It is actually integral of 1 by root u. So, what is 1 by root u integral? That will become u to the power 1 by 2 by 1 by 2. We can write it like this, plus what we get here, this is 34 outside and this is dx upon, let us make complete the square here, which is the term inside the under root, and what we will do, x square minus 9x plus 20, we know how to complete the square. So, we will write it as x minus 9 by 2 whole square. So, x square will come, minus 9x will come as a term of 2ab, plus 9 by 4 is extra. So, we have to subtract 9 by 4 from 20, that will give you 80 minus 9 by 4, that is root over 71 by 2 whole square, if you remember how we used to do the completing the square. So, this term can also be written like this. So, here only one place x is found, here there were two places, one was x square and one was x. Let us write u as x square minus 9x plus 20, and if we try to integrate this, this is plus 34, let us write here, and integration of this, which is actually we have a formula which we did in indefinite integration, that integral of dx by root over x square plus a square is equal to log of x plus root over x square plus a square. So, if we remember this formula, we have to apply the same formula here. So, here instead of x, we have x minus 9 by 2. So, we will say plus 34 log of mod of x minus 9 by 2 plus root over x square plus a square, which is this, which is eventually this term, that is x square minus 9x plus 20, which we converted into this and made it a perfect square. So, in order to solve, we have made it a perfect square, and the final answer we are again writing in terms of this plus constant of integration. So, you see that the answer of this question is actually this 6 root over x square minus 9x plus 20 plus 34 log of this particular term. So, this is the fourth question, which is of 2 marks. Now, we will come to fifth question. Fifth question is find the antiderivative of cos x by 1 minus sin x 2 minus sin x. It is also a 2 marks question. So, in this question, cos x by 1 minus sin x into 2 minus sin x is given to us. So, here first substitution we have to do, that let us take sin x is equal to t. If we take sin x is equal to t, we can say that cos x dx is equal to dt, that is the derivative of sin x, and we can write this integral I as cos x dx become dt, and this will become 1 minus t into 2 minus t. Now, again partial fraction, which we studied in the previous lectures. We can write 1 by 1 minus t into 2 minus t as a by 1 minus t plus b by 2 minus t. Now, what should be a and b, that we have to find out. So, when we take the LCM here, 1 minus t, 2 minus t in the denominator will cancel. We will get 1 is equal to 2a plus b as a term and minus t common a plus b. So, we see that we can write it like this also, which means that 1 is equal to 2a plus b, and since there is no term of t here, so t has a coefficient 0 here, which is equal to minus of a plus b, which implies that a from here is equal to minus b, and we put it here, then in that case a is equal to 1 and b is equal to minus 1. So, this a1 b minus 1, if taken here, it term, this term and this term is actually same. So we can use this concept and write 1 by 1 minus t into 2 minus t like this, which means a is 1, so 1 by 1 minus t dt, and b is minus 1, so minus 1 by 2 minus t, let us take it as dt. What is the integration of this? 1 minus t is log of 1 minus t with a minus sign because t has a coefficient negative. Here we will get plus log of 2 minus t plus constant of integration. So this will become log of 2 minus t upon 1 minus t plus c by the property of log. So the final answer can now be written as, since we took sin x as t, so the final answer for this will be log of 2 minus sin x upon 1 minus sin x plus constant of integration. This is the integral of this term. If we want to verify, we can differentiate this, and we will see that after simplifying we get this result which is inside the integration. So this was another question of 2 marks which was given to us, and it was based on the concept of partial fraction. Now let us come to the next question of 4 marks. Question number 6 says find the integral of sine inverse 2x by 1 plus x square. So in this question number 6 it is said find the integral of sine inverse 2x by 1 plus x square. So some substitutions are specific. Here you have to understand that x has to be substituted as tan theta. Why we are putting it as tan theta? Because if we put x as tan theta, the term inside the sine inverse will become 2 tan theta by 1 plus tan square theta, which by the trigonometric formula is nothing but sine 2 theta. So that helps us to get rid of this sine inverse, and we get a simple term as 2 theta. So we can write, if x is tan theta, dx is sec square theta d theta. In that case, this I becomes integral of sine inverse, the term inside is sine 2 theta after the substitution, and dx is sec square theta d theta. This becomes integral of twice of theta sec square theta d theta. Now you know, students, what we have to do here? We have to, along with substitution, understand the concept of integration by parts. So here there are two functions, theta and sec square theta. Which function will be first and second? So this function is going to be the first function, this is going to be the second function. Isolate A comes first, algebraic, and then trigonometric function comes. So we say 2, first function, integral of second will be tan theta, minus integral, derivative of first will be 1, and integral of second will be tan theta again, and integral of this. This will become is equal to twice of theta into tan theta minus, what is integration of tan theta? It is log sec theta, right? So now we have got the answer, but not in its proper form in which we want, because we substituted x as tan theta. So if x is tan theta, can we find sec theta? Yeah, sec theta will be root over 1 plus x square. X is tan theta. So we can write this I is equal to 2 theta, that is 2 tan inverse of x, into tan theta, which will be x actually. So we write x before to avoid any confusion. So 2x tan inverse x minus 2 log sec theta is root over 1 plus x square. We can take 2 from here and take it as a power here, and we can cancel this square root. So we get this as our answer, plus constant of integration, of course. So we get this as the answer of the integral of sine inverse 2x by 1 plus x square, students. So after this we come to the next question, that is the 7th question. 7th question, as we see, is again a 4 marks question, and it says find the integral of root over x square minus 8x plus 7. So let us find out what should be its integration. Root over x square minus 8x plus 7. So again we know how to make a perfect square, how to complete the square. So x square minus 8x will take part in completing the square, and we can write it as x minus 4 whole square. That will give you x square minus 2ab, that is minus 8x, plus one extra term plus 16. So we have to subtract 16. So 7 minus 16 is minus 9. So after you will open it and simplify, you will get nothing but this. This can be written as, now if you remember a formula, direct application of a formula is root over a square minus x square dx, which comes out to be, you have to remember those formulas, don't try to avoid remembering, a square minus x square, this is what you will do as the first term, plus a square by 2 sine inverse of x by a. I also told you the method how to remember this formula. So x root over a square minus x square by 2 plus a square by 2 sine inverse x by a. This is the formula which we have to apply. So what is, this is a square minus x square, and we have to apply the formula of x square minus a square. So okay, no problem. We can remember the formula for x square minus a square also. So this will be x by 2. This will be x square minus a square, and there will be slight change over here. It will become minus a square by 2 log of x plus root over x square minus a square. Okay, students? If you remember, this formula also we studied, an earlier formula also we studied. Among these two formula, which formula has to be applied here? X square minus a square. So x is actually x minus 4 here. It's a simple linear extension with coefficient of x as 1. And a square is 9, that is a is 3. So we can write that this integration is x by 2, that is x minus 4 by 2 into root over x square minus a square. That term is whole of this, which is on simplification give you this. So can we write it directly, x square minus 8x plus 7, as our purpose of applying the formula has completed. So we can again back simplify it and write it like this. Minus a square by 2, minus a square by 2 means 9 by 2, and log of mod of x minus 4, which is actually the taking the place of x, plus root over x square minus a square. If you find x square minus a square, this is the term which is actually x square minus 8x plus 7 again. So we write it like this, mod of this plus constant of integration. So this is what you will get as an answer of this question. This question does not need many thoughts, but this need actually the application of the formula and how to apply those formulas. So you have to remember all those formula which we have studied in indefinite integral, and you have to remember all those properties which we have studied in definite integral, so that you can easily apply them. Let us come to the next question, which is the 8th question, and that question is also again of 4 marks. It says that integrate 2 plus sine 2x divided by 1 plus cos 2x e to the power x. So 2 plus sine 2x upon 1 plus cos 2x e to the power x dx. So this type of question can remind you of some form. Have we studied some form of exponential function in indefinite integration? Yes, we studied. What was that form? Integration of fx plus f dash x into e to the power x dx comes out to be integral of fx into e to the power x plus c directly, and we also studied the proof of this. We used to apply the by part method in one of them, and will remain one of the other, and finally one term will cancel and we get this as the final answer. If you remember this, you can see in the previous lectures. So we know that this is a formula we have. Can this formula be applied here? No, not right now, because we can't see that a function and there is a derivative of function which are adding up. So can we make it in such a manner? Let us try. So we can see that this I can also be written as, if we write it as 2 plus 2 sin x cos x by trigonometric identity, 1 plus cos 2x can be written as 2 cos square x. It is also a trigonometric identity, e to the power x dx. Now 2 will get cancelled from numerator and denominator. 1 by cos square x can be written as sec square x, right students? Plus sin x cos x by cos square x will be written as tan x. Okay. So this is finally reduced to this form. Can we apply this formula now? Yes. Here the function fx is actually tan x and the function sec square x is actually derivative of tan x. So we can say it is of this form. So final answer should be fx e to the power x, that is tan x into e to the power x plus constant of integration. So all these tricks and techniques to solve the questions we have to also remember, so that we don't get indulged in long derivations and all those techniques. Next, let us come to the 9th question, which is a 6 marks question. It is saying evaluate the following definite integral as limit of sums. So it is integral 0 to 4 x plus e to the power 2x dx. So you have to find the integration of 0 to 4 x plus e to the power 2x dx, and it is quite easy if you do it by the fundamental theorem of calculus, but we don't have to do it by that way. Where how we have to do it? By limit of sums. So if you remember, we used to write it like this. If a to b fx dx is given, we can write it like this: limit n tending towards infinity b minus a upon n into sigma of r equal to 0 to n minus 1 function of a plus r b minus a by n. Correct, students? So this is what we remember for limit of sum. Now if this has to be solved by limit of sum, what we will write? We will say that this I, which is like this. Now first also find out what are a, b and function. So a is actually 0 here, b is actually 4 here, and the function fx is actually x plus e to the power 2x here. So keeping these things in mind, let us express this I as a limit of sum. So we can write limit n tending towards infinity, b minus a by n will become 4 by n because a is 0, and summation of r equal to 0 to n minus 1, f of a plus a will become 0. So f of r b minus a by n, b minus a by again 4 by n. So we can say f of r into 4 by n. We can write it like this. Okay, students. Now what is the function? Function is given as, we can write it 4, let us take outside, limit n tending towards infinity 1 by n, summation r equal to 0 to n minus 1. The function is given x plus e to the power 2x. So this will become 4r by n, which is x, plus e to the power 8r by n, that is e to the power 2x. Now if you analyze this particular series which we have written here, so first series, let us split this summation into 2 parts and then let us talk about the series. Limit n tending towards infinity 1 by n, summation of r equal to 0 to n minus 1, 4r by n, this is the first one, plus summation r equal to 0 to n minus 1, e to the power 8r by n. This is what we have. Now first let us take this 4 which is a constant and n which is a constant for this summation outside. So we write it here, and the summation of r we are doing actually here. So this 4r by n, 4 by n is outside and this r is here. What happens to e to the power 8r by n? We can write it like this: e to the power 8 by n to the power r. Okay, students? Now this is a summation of consecutive natural numbers from 1 to n minus 1. As r equal to 0 will give you 0, so it does not contribute anything. Next term will be 1, next term will be 2, then 3 till n minus 1. So summation of n natural numbers, consecutive natural numbers from 1 to n in arithmetic progression, we have studied that it is n into n plus 1 by 2. So we can say that if we apply that AP formula or the sum of series formula of n natural numbers, we instead of n use n minus 1. So n minus 1 into n minus 1 plus 1 will be n by 2, and there was a 4 by n which was outside. This is what we get. Further, plus what is this series? If you observe, for this e to the power 8 by n is a type of constant. So a constant to the power r where r is from 0 to n minus 1 actually means this is a GP, sum a plus a to the power 1, a to the power 2 till a to the power n minus 1. So we apply the formula for GP, geometric progression. So first term a, that is 1 basically, this to the power 0, 1 minus r to the power n, that is e to the power 8 by n, is the common ratio to the power n, that is the total number of terms from 0 to n minus 1 is n, upon 1 minus r, 1 minus e to the power 8 by n. So this is what we have written here. Next, let us take this n which is outside of the bracket inside. So this n will go here, this n and this n cancels. This extra n will go here, and 4 by 2 is 2, will give you 1 minus 1 by n. This n will go here, plus this n will cancel, well, we will get 1 minus e to the power 8 upon 1 minus e to the power 8 by n. This is written as 1 minus e to the power 8 by n, and this n goes inside, it goes here like this. Now in the first term, if we put n tending towards infinity, this term will be 0. So you can directly say that the first term is 2. Plus, what about the another term? Limit n tending towards infinity, 1 minus e to the power 8 divided by 1 minus e to the power 8 by n. Let us take this n as the denominator of denominator, then it will become 1 by n. We can write it like this. This n goes here, but it can't go as a n, it will go as a 1 by n. So why we have written it like this? This particular term is resembling a formula of limits. What was that formula actually? That formula was limit x tending towards 0, e to the power x minus 1 by x is equal to 1. Here this term in this square bracket is 1 minus e to the power 8 by n upon 1 by n, which can be multiplied with 8 here, and 8 can be multiplied to compensate here also. So we can change this 1 by n to 8 by n. Limit n tending towards infinity. So if n is tending towards infinity, this 8 by n term is tending towards 0, and this 8 by n is tending towards 0. So if we consider 8 by n as x, so 1 minus e to the power x by x, where x is tending towards 0. Here it was just of opposite sign, so it is minus 1 here. We will take this here, and this here we will take a minus sign. So with the help of that formula of limit, we can now write this term as 4 to 8 plus 4 and apply limit here. Whole of this term will finally become as minus 1. So what we can write here is 4, this 8 in the denominator, and minus 1 sign is taken above, e to the power 8 minus 1 it will become. So we can write the final answer as 8, this will become minus 1 by 2, that will become 15 by 2. This will become 1 by 2 with a minus sign. So 8 minus 1 by 2 is 15 by 2 plus e to the power 8 by 2. So we can write it as plus e to the power 8. This is the answer of this question by limit of sum method. Even if we directly apply the definite integration formula of fundamental theorem of calculus, we will get the same answer. You can cross check. Just integrate x as x square by 2, e to the power 2x as e to the power 2x by 2, and put the limits. You will get the same answer. So this is just to know that how can we do it by limit of sums method. After this question, let us come to the last question of today's lecture, which is also of 6 marks. So there are 2 parts. First part is saying that find the definite integral of mod of x minus 5 from lower limit 2 to upper limit 8. So let us take the first question first. 2 to 8 x minus 5 dx. What we need to do here, since modulus function will change its definition at the critical point, which is 5 here. So we will split it in 2 parts, 2 to 5, where modulus will become minus x minus 5, because x is less than 5 in this interval 2 to 5, plus 5 to 8, where x is actually greater than 5. So it will simply be x minus 5 dx. Now we will integrate as we know. So here we have again applied the third property which we studied. So this will become minus x square by 2 plus 5x from 2 to 5 plus x square by 2 minus 5x from 5 to 8. Put the limits. This will become minus 25 by 2 plus 25 plus 2 and minus 10. This will become plus 32 minus 40 minus 25 by 2 plus 25. So if you observe, we have to just find out the solution. Minus 25 by 2 and minus 25 by 2 will add to minus 25, which will cancel with this plus 25. So all these three terms will cancel. Minus 40 minus 10 is minus 50. Minus 50 and plus 25 is actually minus 25. Minus 25 and this is 32 plus 2, 34. So 34 minus 25 will be, let us write it here, 9 units. So we get 9 units for this. Okay, students. Now let us come to the second part of this last question. If we see the second part, as we see here, it is integral of 0 to pi by 4 of log 1 plus tan x, and we have to find this by using the property of definite integral. So let us solve this question. Question number 10, second part. It says that I is given as 0 to pi by 4 log of 1 plus tan x. So the property which we have to apply here is again the property which we used in a formula, that is 0 to a fx dx is equal to 0 to a f of a minus x dx. So this I will become 0 to pi by 4 log of 1 plus tan pi by 4 minus x. This is how we can write this and close the bracket. Now the term inside tan is tan of pi by 4 minus x. By trigonometry we know tan of a minus b is tan a minus tan b by 1 plus tan a tan b. And what is tan a? Tan pi by 4, which is 1. So we can write by trigonometry tan pi by 4, which is 1, minus tan x upon 1 plus tan pi by 4, which is 1, into tan x dx. Now let us take the LCM inside log. This is actually pi by 4, not pi by 2, as it is given in question. So this will become log of, when we take LCM in the numerator, tan x will cancel and 1 will add to 2. So 1 plus tan x dx. In the next step, this I can be written as, by the property of log, we can write this I as 0 to pi by 4 log of 2 dx minus, since these are in ratio, we can take it in minus and take the log separately by the property of log. 0 to pi by 4 log of 1 plus tan x dx. So this is how we separated this numerator part and this denominator part. Now this part is nothing but I, which was given in the question. So we can say that finally this I goes on the left side, this becomes 2I is equal to, and what is the integral of this? Log 2 is a constant, you will get x, and x after putting limits will become pi by 4. So we will say pi by 4 log 2, which means our final answer I is equal to pi by 8 log 2. This is the answer for this particular question. So these questions which were here were selective questions from this chapter and introduced you to all the concepts which can be covered from the chapter. So try to memorize everything and solve these questions again on your own. Thank you, students.